Alright, so with the sine formulas, you've got the same kind of thing going on. You're just going to use either a sum of two angles or a difference of two angles to help you be able to manipulate whatever you have to become this, which this on the right hand side is something we can compute, whereas the left hand side is something we cannot compute. So same exact kind of strategies here. Okay, all you need to do is find your alpha and beta. Once you find them, plug them in. So find alpha and beta. That's step one. Step two, plug it in. Alright, so I'm not going to do any highlighting here. You can kind of see the similarity from above, and if you want to, you can go ahead and highlight this. So for our next example, I'm going to throw in radians. So it's going to be very similar to the first example, except we're working with sine and we're going to use radians. So find the exact value of sine of 5 pi over 12. So that might look really intimidating because you got 5 pi over 12 and you're like, oh my gosh, how do I figure out what two things go with that? How do I make 5 pi over 12 out of my special angles? Well, first let's remind ourselves, what are our special angles in radian? So 30 degrees is pi over 6. Now, I just know this. If you don't, that's okay. If you don't believe me, go back and look at like skill 2 where we converted, and you'll see if you convert this, it'll be pi over 6. And 60 degrees is pi over 3, and 45 degrees is pi over 4. 0 degrees is just 0. 90 degrees is pi over 2. 180 is pi. 270 is 3 pi over 2. So now you can see those are all of our radians. The tricky thing with radians is you, in order to break something apart, like we've got here, this sine of 5 pi over 12, you have to get common denominators. So what we're going to do in this example is we have to first of all change all of these special angles to have a denominator of 12 and figure out which ones are going to fit together to be able to use one of these identities. So over here in our notes, let's first do 5 pi over, pi over 6 is equal to what over 12? Hopefully you all know, 2 pi over 12. Pi over 3 is equal to what over 12? 4 pi over 12. I just multiply top and bottom by 4. Pi over 4 is equal to 3 pi over 12. So let's just stop there before we do a bunch of extra work, and let's see, can we create a sum or a difference out of these special angles that will equal 5 pi over 12? So can we add any of these together or subtract any of these from one another to get 5 pi over 12? And hopefully you see that these two, if we add them together, they're going to equal 5 pi over 12. So we don't need to do any extra work. Over here, we're going to write sine of 5 pi over 12 is equal to sine of 3 pi over 12 plus 2 pi over 12. And the order doesn't matter, okay? So if you're wondering, does it matter which order I put it in? No, it'll come out to the same thing. So now we're going to use our identity. This is alpha, and this is beta. We've got a sum, so we're going to go over and we're going to use this identity. So alpha, beta, we're going to plug them in. So now we have sine of alpha, 3 pi over 12. I'm just going to write that as pi over 4. Then we have times cosine of beta, which is 2 pi over 12. I'm going to rewrite that as pi over 6. Then we've got plus cosine of alpha, so cosine of pi over 4, times sine of beta, and beta is pi over 6. So you can see the similarity between this and this is just a little bit more difficult because of the fractions. So now we actually find sine of pi over 4. That equals square root of 2 over 2. Cosine of pi over 6, I need to draw my triangle for that one. So here's pi over 6, here's pi over 3. I know that square root of 3 is across from pi over 3, and I know 1 is across from pi over 6. 2 is the hypotenuse. So cosine of pi over 6 is times the square root of 3 over 2. Then we've got plus cosine of pi over 4 is the square root of 2 over 2 times sine of pi over 6, which is 1/2. Okay, we're almost done now. Now we can actually multiply each of these. So we're going to multiply and get square root of 6 over 4. And here we're going to get square root of 2 over 4. And remember, you can leave it like that, or you can combine using common denominators and write square root of 6 plus square root of 2 all over 4. And that's going to be the exact answer instead of the decimal. Alright, so the key here, the key takeaway, is that before you actually get started, you're going to have to take those special angles or your quadrantal angles and get a common denominator with what you're looking for. Now let's move on to tangent.